Hey, what's up year 4 guys? It's Matt the Maths guy here, and I am here to teach you a lesson today on multiplication and division. We're going to split this lesson into 9 categories, and we're going to start by looking at multiplication grid method before we move on to multiplication expanded method. They're going to be our main sort of chunks of the multiplication lesson. Then we're going to look at some long division before looking at some inverse operation, which is how we can go back from multiplication to division. Then we're going to look at multiplying and dividing by 10, 100, and 1000. Then we're going to try and see how we can get the lowest common multiple of any set of numbers. And then we're going to try and find the highest common factor. After that, we're going to look at 2 pretty tricky things. The first is the commutative property, and the second and the last thing on our lesson is we're going to be looking at the distributive law. And that's super challenging, so make sure you stick around for that. But let's waste no more time, let's get into it, starting with grid method. Okay, we're going to look at these 3 questions. We've got a green, an orange, and a red chili challenge. They get progressively harder as we go forward. But first, let's look at our steps for grid method. First step we're going to do is partition our numbers. We're going to understand what that means in a little bit. Second, we're going to multiply the individual parts. And then third and finally, we're going to add those individual parts back together to get our final answer. So let's have a look at our green chili challenge. So our green chili challenge is 23 times 45. So our first step said to partition our number. So what that means is we're going to look at the number 23 and we're going to understand that we can partition this into a 20 and a 3 because 20 plus 3 equals our 23. So we can do the same to 41 and it would be 40 and 1. And once we've done that, we can make our grid. So my question was a 2-digit number by a 2-digit number. So therefore, my grid will be 2 lines by 2 lines. And now simply I'm just going to put my number in place in the partitioned form. So 23 and 41. Put the multiplication sign, but at this point, let's tidy this up a little bit. Boom. Okay, so now I'm ready to start to answer my question. Now, the way that we work with these grids, this box here will be the product of 20 and 40. This box here will be the product of 3 and 40. This box here will be the product of 1 and 20, and this box here will be 1 and 3. So let's have a go. Okay, so the first question is 20 times 40, but 20 times 40 is still quite difficult. So what I can understand is that 20 times 40, I have 2 zeros. So what I can do is just temporarily ignore these for now and do 2 times 4. Well, 2 times 4 is 8. And now I have to put my zeros back because what I've done is I've done 2 times 4, but my question was 20 times 40. And there's 2 zeros in that, 1 in the 20 and 1 in the 40. So it's actually 100 times larger. So the answer is 800. Okay, let's apply the same logic to the second part, and I have 40 times 3. I'll ignore the 0 to start with. 4 times 3 is 12. Put the 0 back, 120. Now I'm doing 1 times 20. Well, 1 times 20 is 20. And then in the last box, I have 1 times 3. 1 times 3 is 3. But am I finished? No, because if I look back at my steps, I now need to do step 3, which is to add these numbers back together. Because so far I've broken this question down into smaller parts, now I need to put it back together again. So I need to add my 800 to my 120, my 20, and my 3. And here we go. 0, 0, 0, and 3 equals 3. 2 and 2 is 4. 8 and 1 is 9. So my answer to 23 times 41 equals 943. Okay, let's look at our second challenge, our orange chili challenge. We have 78 times 53. Now I'm going to jump straight into making my grid this time. 1, 2, 1, 2, and I'm going to have 78. I've still partitioned, but I've just skipped a step, and 53. Put my multiplication sign, and let's tidy it up. Okay, so the first question is 50 times 70. Well, again, I don't like 50 times 70. I'm going to make it 100 times smaller and work out 5 times 7. 5 times 7 is 35. So put my 35 in place and then put back my 1, 2 placeholders. Next question says 50 times 8. So I'm just going to do 5 times 8, which is 40. Put back my 1 placeholder. 400. 3 times 70, so I'm just going to do 3 times 7. 3 times 7 is 21, and put back my placeholder. And then last question, 3 times 8, there's no placeholders, it's just 3 times 8. 3 times 8 is 24. Am I finished? Not yet, because I partitioned, but I've not added them back together, so let's add them back together. Here we go. Okay, and in my ones column I have 0, 0, 0 and 4 equals 4. In my tens I have 0, 0, 1 and 2 equals 3. And in my hundreds I have a 5 and a 4 and a 2, which is 11. And in my thousands I have 3 and my new one, 4. So my answer is 4,134. Okay, let's look at our last question. Let's look at our red chili challenge, 125 times 46. Now I'm going to let you in on a secret. This is actually not any harder. It's just a bit longer with another step. So what we can see is we now have a 3-digit number, which means we're now going to have 3 lines in our grid. It doesn't matter which way around, because remember, multiplication is commutative. 125 times 46 is the same as saying 46 times 125. So I'm going to choose to have 3 horizontal lines, 1, 2, 3, and 2 vertical. Put my numbers partitioned, 125 and 46. Let's tidy it up. Okay, here we go. So my first question is 100 times 40. Now I can see I have 1, 2, 3 zeros that I'm going to ignore for a moment, and just times 1 times 4, which is 4. And now I have to put my 1, 2, 3 back in. So 40 times 100 is 4,000. Okay, and now my 100 times 6 is 1 times 6 is 6. Put back my 2 zeros. 20 times 40 has 1, 2 zeros. So 2 times 4 is 8. Put back my 1, 2 zeros. Then I have 20 times 6, 1 0. 2 times 6 is 12. Put back my 1 0. 5 times 40, ignore my 1 0. 5 times 4 is 20. Put back my 1 0. And last but not least, 5 times 6 is 30. Now I have a longer one to add up. Again, it's not that much harder, it's just a bit longer. So here we go. In my ones column, I have all zeros, so my answer is going to be 0. In my tens, I have a 2 and a 3, which is 5. In my hundreds, I have a 6 and 8, which is 14, plus the 1, 15, plus the 2, 17. And in my thousands, I have the 4 and the new 1, 5. So my answer to 125 times 46 is 5,750. Okay, let's just check our things to remember for grid method then. First is to partition the numbers. We need to partition the numbers so that we have more manageable chunks to multiply. Then we're going to put the numbers into our grid and multiply the individual parts separately. But remember, if a number has a 0 at the end, we can give it the special treatment of ignoring it for now and then putting those zeros back into our answer. And then finally, when we've done all the sections, our last tip is to add those bits all back together so that we get our grand total. Okay, this is your time to press pause, have a go at these 3 questions that are on the screen and put your answers into the comment section so that I can give you a mark. Okay, hopefully you got on well with that. Now let's have a little look at expanded method. This is the next step on past grid method. So once you fully understand grid method, we can start to move into expanded method. It's very similar, but it lays out our question in a more traditional way, ready for those next stages that are going to come after this. Good luck, let's start. So today we're going to look at these 2 questions. We've got a green chili challenge of 43 times 25, and we've got a red chili, a harder challenge, 82 times 64. So let's begin with our green chili challenge, 43 by 25. Now the first thing we want to think about doing is making sure we're organizing our work nice and neatly before we begin. So I'm going to make sure I start by putting my ones, tens, hundreds, and then I can enter the numbers in the correct places. 43 times 25. Put my equals line, and I'm ready to begin, but let's just tidy that up. So let's begin. Now, where do we start? Well, we always start with our smallest values. And in this question, we have a ones column. So ones will be our smallest value. So we're going to multiply our 5 times our 3 to start with. So my first question will be 5 times 3. Then I want to think about what's the second smallest value. Well, if I continue multiplying this 5, but move up now to my tens, I'll be multiplying 5 by 4. Well, it's not a 4, is it? It looks like a 4, but it's in our tens column, so it holds the place of 40. So my second question says 5 times 40. Now I've multiplied my 5 by the 3 and by the 4, which means that between my 5 times 3 and 5 times 40, what I've actually done is 5 times 43. Now I'm going to look at the second digit in this number, the 2. And we know it's not a 2, it's actually a 20. So my first question should be 2 times 3, but like we say, it's not a 2, it's a 20. So 20 times 3, and then my last question would be 2 times 4, or 20 times 40. And now I'm ready to begin. So here goes. 5 times 3 is 15. 5 times 40, well, I might not know that, so I can just use my knowledge of place value and put my 0 in place, and then just do 5 times 4. 5 times 4 is 20. So the answer to 5 times 40 would have been 200. Now I've got 20 times 3, again, put my placeholder in place. 2 times 3 is 6. My next one says 20 times 40. This time I've got 1, 2 placeholders, so I put 1, 2 placeholders in place, and I can do 2 times 4 is 8. Looks finished, but is it? No, not yet, because so far we've partitioned our number, we've broken it all down into the individual parts. Now I need to smash it back together to add it all up. So now I'm going to add up all of these individual parts. So if I start with my 1s, I've got 5, 0, 0, 0, that equals 5. And if I then look at my 10s, I've got 1 and 6, that equals 7. And in my hundreds column, I've got 2 and 8, that equals 10. So my answer is 1075. Okay, so my next question is a red chili challenge, one that's a bit harder. Why is it harder? Well, these numbers might be a little bit harder to multiply. So let's start at the right place. Let's put our 1s, 10s and hundreds, and then we put our numbers in place. 82 times 64. Put my equal line, and I'm ready to begin. But let's just tidy it up. There we go. Okay, so let's remind ourselves, where do we start? Well, we start at our smallest value, so my first one's going to be 4 times 2, and then I start moving to the next smallest value, 4 times 8. Not an 8, is it? We know it's an 80 because it's in the tens column. So now I've done the 4, I'm going to move on to the 6, and I'm going to do 6 times 2, but we know it's also not a 6 because it's in the tens column, so it's 60 times 2, and then my last question would be 60 times 80. Put my equals line, and I'm ready to begin. Here we go. 4 times 2 is 8. 4 times 80, not sure, so I'm going to use my place value, put my 0 in place. Now I can do 4 times 8. 4 times 8 is 32. Put that in place. So 4 times 80 is actually 320. Now I've got 60 times 2. Put my placeholder in place. 6 times 2 is 12. Now I've got 60 times 80. I've got 2 placeholders. 1, 2. 6 times 8 is 48. Okay, and then we can just simply add those columns up. 8 plus 0, 0, 0 is 8. 2 add 2 is 4. 3 add 1 is 4. Add the 8 is 12. So carry a 1 over. 4 add the 1 is 5. So my answer to the red chili challenge is 5,248. Wow, well done. If you carried along with me with that, that shows you got a good understanding. Let's think about the things we need to remember. Always put your 1s, 10s and hundreds as your column titles. That's going to help you avoid any mistakes. Partition the question into all of its individual parts, like we did here, where we thought about our 4 questions first. 1, 2, 3, 4. That's really important. Don't forget your placeholders. It's going to make the multiplication much easier. And then don't forget that you've individually answered these separate parts. You must put it together to get a final answer at the end. Okay, I've got 3 questions here on the board for you. I want you to have a go at all 3 of these. Put the answers in the comment section, and I'm going to try and mark every single one. Good luck. Okay, there's our multiplication out of the way for a moment. Let's have a look at long division. This is a really important skill to learn. It's going to be using the bus stop technique. So let's start. We have 4 of them here that we're going to work through together. It would be a good idea to get a piece of paper and a pen and try and work these questions out as we go along. So let's begin. We're going to first start with this question here. It says 36 divided by 3. So the first thing that we're going to do is put our 36 inside what we call this bus stop, and we'll put the 3 on the outside. And we call this 3, this is the divisor, and the 36 we call the dividend. And what we're doing here is we are sharing our dividend between our divisor. We need some steps to help us answer this. And the first step is going to be to divide. And then we're going to do step 2, which is to multiply and find out how many we took away from our 36 each time. Then we'll subtract that group, and then we'll pull down the next digit and work on the next column. So let's see what that looks like. Okay, so the first question does say how many 3's are there in 3, because I'm dividing my 3 by this 3 here, but we know it's actually a 30. And I know the answer to how many 3's are there in 3 will be 1. there is one group of 3 in 3. If I had 3 marbles, then I could take one whole group of 3 away. Okay, and now what does step 2 mean? Multiply the groups. Well, what I'm going to do is I want to work out how many of my 36 I've just worked out in that first step. So if I times 1 by my original 3, I'll get 3. 1 times 3 is 3. If I subtract that from my question, I will end up with a 0 in this tens column, and then I can pull down my 6, and I will end up with a 6 in the ones column. Now I can go back and do step 1 again, divide. So how many 3's are there in 6? Well, there are 2 3's in 6. Okay, but I'm not quite finished. I need to do step 2, which is to find out how many groups I've just taken away. So 2 times 3, take that away, leaves me with 0. And this is what we call the magic 0, because this is what we want to get down to at the end of this kind of question, because that shows us that we've finished this question and that we have our final answer. So 36 divided by 3 equals 12. Good job. Okay, let's move on to a slightly harder question. Let's have a look at this question here. 656 divided by 4. So we're going to have the same steps again, and I'm going to put my dividend of 656 inside my bus stop and my divisor 4 on the outside, and I can just do the same thing again. So how many 4's are there in 6? Well, if I have 6 marbles, I can take one group away. I couldn't take another group because I haven't got a full group of 4. So I've got 1. But now when I do my multiplication to find out how many groups, we're going to get a slightly different result. So let's do it. Let's see. 1 times 4 is 4. And that's going to leave me with 6 subtract 4 is 2. Now I can bring down my next digit. I'm not going to bring the 6 with it. I'm just going to bring the 5 at this point. And I have 25. Now I can ask myself, how many 4's are there in 25? So 4's into 25, we can count up in our multiplication table if we want to try and do it that way. 4, 8, 12, 16, 20, 24, and I can't go to 28 because that would be more than 25 and that would be too many. So the answer is 6. And let's see how many we took away that time. So 6 times 4 equals 24. Take that away and I'm left with 1. Bring down my 6 and I'm ready to answer my final part. How many 4's are there in 16? 4, 8, 12, 16, we have 4. Now I can do my 4 times 4 and I work out that that's 16. That 16 subtract 16 is 0, my magic number, meaning that we've finished this question. So 656 divided by 4 equals 164. Good job. Okay, let's look at a slightly different one. This one's going to be a little bit tricky. Let's have a look at 146 divided by 5. Okay, so same thing again. I'm going to put my 146 inside my bus stop and my 5 on the outside. And I'm going to follow step 1 again. So how many 5's are there in 1? Well, if I have 1 marble, I can't take any groups away, can I? So the only thing I can do is put a 0. I took 0 groups away. But now, when I do my multiplication, I can work out that 0 times 5 is 0. I took 0 groups away. 1 subtract 0 still leaves me with 1. Bring down my 4, just like before, and now I have 14. Now I can ask myself, how many groups of 5 are there in 14? 5, 10, 15. 15's too far, so I have to stop at 10, so therefore there's 2 groups. 2 times 5 is 10. Subtract the 10 leaves me with 4. Bring down my 6. How many 5's are there in 46? Again, we're going to use our times table knowledge. 5 times 9 is 45, so there's 9 lots.
But then when I do my 9 times 5, I see that I have 45, and when I subtract that, I'm left with 1. And if we remember, there are no groups of 5 in 1, so I can't do another division. What I have to do with this 1 is consider it a remainder, 1 left over. So my answer is 29 remainder 1. So the answer to 146 divided by 5 is 29 remainder 1. If you want to learn how to change this remainder into a decimal, you can watch that video on this channel as well. Okay, let's do our final one. Let's do a big one. We've got 3,986 divided by 6. Okay, same process again. I don't think this is any harder, just a little bit longer. So here we go. First question is, how many 6's are there in 3? There are 0, and therefore 0 times 6 is 0. Subtract that away from my 3, and I still end up with 3. Pull down my 9 to answer the next question. How many 6's are there in 39? 6, 12, 18, 24, 30, 36. Can't get to another number, so we have 6. 6 times 6 is 36. Subtract 36 from 39 leaves me with 3. Now I can pull down my 8. And my next question says, how many 6's are there in 38? 6, 12, 18, 24, 30, 36. I can't go any higher than that again, so I have 6. Again, 6 times 6 is 36. 38 subtract 36 is 2. Bring down my 6. How many 6's do we have in 26? I have 6, 12, 18, 24, so I can take 4 whole groups away, and 4 times 6 is 24, leaving me with 2. 2 is smaller than 6, so therefore we can't take a group of 6 away, so that's going to become a remainder. Simple.
Okay, now we've had a little look at multiplication and division. Let's have a little look at inverse operations and see how we can go from one to the other and see how that will help us not only check our answers to make sure we've got the right answer, but also to help us with some missing number problems. Let's start. Okay, we're going to be looking at two different style of questions here. We've got our green chili challenge, which is just a division question, and we're going to inverse it into a multiplication. And then we've got a missing number problem as well that we're going to see how inverse can help us solve. Okay, so let's start with our green chili challenge, our first question. So we have 15 divided by 5. So we know that if we have 15 divided by 5, we're going to get an answer of 3. There are 3 5's in 15. So what does inverse mean? Inverse essentially means the opposite. So division is the opposite of multiplication. So we can use these same numbers to create another number sentence, which is multiplication. So let's see how we can do that. But let's have a little think about what we know about number before we start. We know that when we're dividing a large number by a smaller number, we are going to get another small number, a number smaller than our first starting number. Therefore, it's logical to think that this number here, the 15, if we are making a multiplication question, will end up being the answer because two smaller numbers multiplied together will equal the bigger number. So therefore, my number sentence for my multiplication would be 5 times 3 equals 15. And let's check it, 5 lots of 3, yes, equals 15. But I can see another number sentence here that would also work. What if we flip the 5 and the 3 around and we used our commutative law? And I put 3 times 5, and I also know that 3 times 5 equals 15. So using the same numbers, so far I've made 1, 2, 3 separate number sentences. Well, I can actually see another one. I can see another division question because I think that if I get my 15 at the start again, and this time I divide by 3, I'm going to get 5. So with the same set of numbers, I've actually managed to create 4 number sentences, and these 4 number sentences together are called the number family. And every question will have a number family, a different way of expressing the numbers using different operations. In this case, we have 2 multiplication and 2 division questions. Let's have a quick look at another one. Let's say I have 25 times 4
equals 100. Okay, so if now I'm wanting to find the opposite, the inverse, I can try and think about my number knowledge again, and I can see that my larger number here is 100. So if I'm wanting to create a division question, I'm going to need to put my larger number at the start. So now I can have 100, and knowing what I know now about my number family, it doesn't matter which way around I put my 25 or my 4, because it's still going to be part of the number family. So I can say 100 divided by 25 equals 4. Or I could write 100 divided by 4 equals 25. Can any of you see the other question that I can have in this number family? I have 2 division and 1 multiplication, which means it must be another multiplication. And yep, I can see it here. I could have 4 times 25. Move those 2 numbers the other way around and I'll still get 100. Okay, so let's use that knowledge to try and help us with this missing number fact then. So here I have a question that says 12 times something equals 48. And this is a very common question that you're going to see in exams. So I can see this is a multiplication question. So I know that this number and this number will both be smaller than my 48. So therefore, for a division question, I'm going to put my 48 at the start. And I can simply use now the only number that I have available to me, 48 divided by 12. And I know that 48 divided by 12 is 4. Now I can check my answer by doing 4 times 12 should equal 48, which it does. So I've got now 1, 2, 3 of my number sentences. I can now get my other one, my other division question, by putting 48, but instead of dividing it by 12, I'm going to divide it by 4, which equals 12. But the one that really helped us was this one here in order to get our missing number. Let's have a look at another quick missing number. Let's say I put 50 and I divide by something, but it equals 10. And this one's a little bit different because I actually don't need to do the inverse operation because I have one of my division questions, but if I simply put my other division question, which would be 50 divided by 10, still in the same number family, that's going to equal 5. So therefore this question mark here could be replaced with a 5. Let's check it. 50 divided by 5 equals 10. Correct. Let me quickly get my next 2 number sentences, and I can see that 50 is the largest number. So if I'm now going to multiply, that number needs to come to the end, and I could work out that 5 times 10 equals 50, but also flip those numbers around. 10 times 5 equals 50. These are my number family. And there you go. That is using the inverse operation to help you solve both missing number questions and also being able to just check your answers and make sure you've got the correct answer. Let's think about the things to remember. Firstly, inverse essentially just means the opposite. Multiplication is the inverse of division, and addition and subtraction are inverse of one another. And then lastly, a number sentence can have a number family, and those number families can help you with all of what we've just been talking about. Okay, so now it's your turn. I would like you to try and find the 4 number family sentences for these 3 questions. Once you get them, put your answers in the comment section, and I'm going to try and mark every single one. Good luck. Okay, this is a really important skill. We're going to look at multiplying and dividing by 10, 100 and 1000. These are really good numbers to be able to quickly multiply and divide by, so let's see how we can do this. Let's start. So what does it mean to multiply by 10, 100 and 1000, and why are we grouping this into one lesson? Well, the reason we do that is because these are a special set of numbers that are actually quite easy to multiply and divide, so therefore learning a little trick or a method to do this is going to be very, very helpful. So what is that method? Well, we're going to use the place value chart. I've got one here for us. We can see our ones, our tens, our hundreds and our thousands. We've actually got things below the decimal as well. This is our decimal line, and then we have tenths, 100ths and 1000ths. So how can this help us? Well, let's take our first question here, the 56 times 10. The first thing we're going to do is we're going to put our 56 into our place value chart, really focusing on the value of these digits. So in 56, I know that I have 6 ones. So I'll put my 6 in the ones column, and I know that I have 5 tens, so I'll put the 5 in the tens column. Now, when I multiply it by 10, what I'm actually doing is making this number 10 times larger. So to show that, I can just move it one place up this place value chart. And by doing that, I'm making this number 10 times larger. Let me show you what I mean. If I move this 5 into this column, and I move the 6 into the tens column, then I end up with 5 hundreds, 6 tens, and although there's nothing in my ones right now, I would have to fill it with what we call a placeholder or a 0. And now my answer says 560, and 560 is 10 times larger than 56. That's quite easy to see. So my answer to 56 times 10 is 560. Okay, let's see if this can help us with our division question. So now I have 530, and I'm going to put that into my place value chart again. 530 has 0 ones, 3 tens, and 5 hundreds. And this time I'm dividing it. And when we divide something, our number is obviously going to be getting smaller. So this time we're going to move down our place value chart or to the right. And if I'm dividing it by 10, what I'm actually doing to this number is making it 10 times smaller. So here we go. I'm just going to move them one place to the right this time. So now this 0 will come into this column, into the tenths. The 3 will go into the ones column. The 5 will go into the tens column, and I'm nearly finished. The only thing I need to make sure I do is put my decimal in place, because remember this line here represents our decimal place. So my answer is actually now into the decimals, and I've got 53.0. Now anybody that understands number will understand that we actually now don't need to include this 0.0 in our answer. I can simply write 530 divided by 10 equals 53, because this 0 doesn't change the value of my number at all. I could have a 0 here, 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 all down my place value chart, and it's not going to change the value of my number. Okay, let's turn things up a little bit. Let's get an orange chili challenge. I'm looking at 23 times 100, and I'm going to put my 23 in place just like before, but this time I'm multiplying by 100. And when I do that, I now need to make our number 100 times larger than what it is. So to do that, I'm going to move it not just one place up our place value chart, but 2 places. And I can see that because I have 1, 2 zeros in my 100. So to make it 100 times larger, here we go. Let's move them 1, 2 places. So my 2 moves 1, 2 into the thousands column, and my 3 also moves 1, 2 into my hundreds column. Now remember, we've got some blank spaces here before my decimal, so now I need to fill them with placeholders or zeros. Show me that the answer to 23 times 100 equals 2,300, because 2,300 is 100 times larger than 23. Okay, so let's look at our division question. 453 divided by 100. But now I'm dividing, so remember, I'm going to be going down the place value chart to the right. How many times am I going to go to the right? Well, I'm dividing by 100. I need to make it 100 times smaller, so I'm going to move it 1, 2 places, which will make it 100 times smaller. So here we go. I move my 3, 1, 2, I move my 5, 1, 2 into the tenths column, and I move my 4, 1, 2, landing in the ones column. Don't forget to put that decimal, that's super important. 453 divided by 100 leaves me with 4.53, or 4 and 53 100ths. Let's get to that real spicy challenge. Here we go. 87 times 1000. So same rule applies. I'm going to put my 87 in place, but now I'm multiplying by 1000. So how many places am I going to move it to my left? Because remember, when we're multiplying, we move it to the left because we're getting bigger along our place value chart. Well, I'm going to look at my 1000. I can see I've got 1, 2, 3 zeros. So therefore, I'm going to move it 3 places to my left, making it 1,000 times bigger. So here we go. 8 moves 1, 2, 3, I'm coming actually out of my place value chart that I've made, but that's okay because the place value chart can go on forever, and this column here represents 10 thousands. Okay, so my 8 lands in here. I'm going to do the same thing to my 7. 1, 2, 3, and now I have these 3 gaps before my decimal that I now need to fill with placeholders. 1, 2, 3. So my answer to 87 times 1000 equals 87,000 and no decimals. Okay, let's do my last division question. Here we go. And this time I'm dividing, so I need to come down my place value chart because remember, division questions will end up with a smaller answer. I'm dividing by 1,000 again, so I have 1, 2, 3 zeros to consider, so I'm going to move them 3 places down my place value chart. But I can see here that I can put my decimal in place, and I have a couple of options. I can call this number 0.421, or I can put a 0 here and call it 0.421. Exactly the same value, just a slightly different way of saying it. So I'm going to keep my 0 and I'm going to say 421 divided by 1,000 equals 0.421 or 0.421 thousandths. Okay, there you go. That is everything you need to know about multiplying and dividing by 10, 100 and 1,000. But let's just look at what to remember. First, we should always make a place value chart, then write the numbers in the chart focusing on the value of each of the digits. Then move the numbers to the left if we're multiplying, or to the right if we're dividing. And then we simply look at what we're multiplying and dividing by, 10, 100 and 1,000, see how many zeros are in that number, and then move the numbers that amount of times. Okay, so now it's your turn. Press pause on the video, have a go at answering these questions again for yourselves. If you need a little bit of help, you can go back and see how I did it in the video, but try and do it on your own. Put the answers in the comment section. Okay, let's start getting a bit challenging then. Let's start to try and find lowest common multiples. This is a really important skill as we're going to use the lowest common multiples in other areas of maths. So let's start. Okay, we're going to look at these 2 questions, 5 and 12 and 3 and 11. But before we do that, let's first think about what lowest common multiple means. And let's think about it word by word. So multiple. A multiple means any number that is in the multiplication table of our given number, the number that we're discussing, in this case 5 and 12. So think about the numbers that are in the 5 times table, 5, 10, 15, 20, 25. They are all multiples of 5. And 12, 24, 36, they are all multiples of 12. So a multiple is just the numbers that are in the multiplication table of the number that we're thinking about. Or a fancy way to think about it is a multiple is the product of our number multiplied by any integer, an integer being a whole number. So for example, 5 times 3 equals 15. 15 is the product, 3 was the integer we multiplied our number by, and therefore 15 is a multiple of 5. Okay? Common just means the same, together. So it means if I'm trying to find the common multiple, it wants me to find how many multiples are in both the 5 and 12 times table. And lowest simply means the smallest value. So we're looking for the smallest number that's in both of our multiplication tables. Okay, let's begin with question 1 then. And I have 5 and 12. So I'm looking for that common multiple, the lowest common multiple. So I need to think about what my multiples are. Let's think about our 5 times table. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Let's stop there. And now let's think about our 12 and think about the 12 times table. So I would start with 12, 24, 36, 48, and 60. Okay, so I found my multiples, and now I think I've found a common multiple. I have this 60. And what I can also see that this is the only multiple that I have here, so therefore it is my lowest common multiple. So I could have carried on and I would have noticed that I would have also 120 in both of these multiplications, but that would not be my lowest common multiple because it's not the smallest number. The smallest number would be this one, the 60. So if we're looking at 5 and 12, the lowest common multiple, and we can say it like that, LCM equals 60. I give myself a tick. Now what you might notice with our lowest common multiple being 60 is that 60 is actually 5 times 12, our 2 numbers. 5 times 12 is 60. So we know that 60 was going to be a multiple, but we don't know if this is our lowest common multiple. So I'm not going to use this method. This method's great for finding a multiple, any multiple, but we don't always necessarily know it's the lowest common multiple. So it's much better to write down a sequence of our multiplication table so we can make sure we get the lowest common multiple. Okay, let's move on to question 2 then, and we have 3 and 11. Now what I think is quite a good tip is to multiply the bigger number first. So I'm going to find some multiples of 11. 11, 22, 33, 44, 55, and I'm going to stay there. And now I'm going to look for those multiples of 3. The reason I think this is a good idea to do it this way around is because now I know when to stop in my 3 times table, because hopefully I will bump into one of my multiples in the 11 table before I have to do too many. So let's go. I'm going to have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Okay, what have I found? I think I found a common multiple. I found 33 in both the 11 times table and in the 3 times table. Now I can see that there's no multiple that's less than that in any of these digits, so therefore the lowest common multiple equals 33. So to find our lowest common multiple, all I need to do is try and draw a list of the multiplication table of both the numbers, find the ones that are common, the ones that are the same, and then look for the lowest one. Okay, I hope that was useful. Here are 3 questions for you. Try and find the lowest common multiple of all these sets of numbers and put the answer in the comment section. I'm going to try and mark every single one. Okay, now I've had a little look at the lowest common multiple. Let's have a look at the highest common factor. Again, this is a really important skill to learn. Hopefully you can get this one. Let's jump into it. Okay, so where are we going to begin? Well, we're going to look at what the phrase actually says first of all, and we're going to think about these 3 words. Let's start with factor. So what is a factor? Well, a factor are any 2 numbers that when multiplied together equal the product of the number that we're talking about. So in this case we have question 1, we're looking at number 6 and number 15. So if any number multiplied together equals 6, they would be the 2 factors, and again for 15. So that's what factor is. Common just means the same, so we're looking for factors that are both in 6 and in 15, and the highest obviously means the highest, the biggest number, the greater value. Okay, so let's put that into practice a little bit, and let's have a look at question 1, and let's have a look at these 2 numbers. So we're trying to find the highest common factor of 6 and 15. So first of all, let's look at the factors then. So if I have the number 6, how can we find our factors? If you haven't checked out the multiples and factors video on this channel, then this is your time to do that, because we're going to go quite quickly through what factors are here and how to find them, but there's much more description in that other video. So we know that the factors are 2 numbers multiplied together equals 6. So we can always start with 1 and 6. We know that 1 times 6 is always going to equal 6. So therefore 1 and 6 are both factors of 6. Okay, let's see if there's any more. Go logically in sequence. 2, and I know that 2 times 3 will also equal 6. Now let's see if I can go any further. Well, if I put 3, we know because I've got 3 here and I've already used a 3, that is as far as I should and could go. So my factors of 6 are 1, 2, 3, and 6. So now we need to look at 15. So if I put 15 over here, what are my factors of 15? Well, I know I have 1. 1 times 15 will equal 15. Have I got a 2? No, because 15 is not divisible by 2. I can't divide 15 by 2. So I have no 2. What about 3? 3 times 5 equals 15. What about 4? Is 15 divisible by 4? 4, 8, 12, 16, so no. And then if we try and use 5, I've already used a 5, so I don't need to do that. So let's have a look. Our factors of 15 are 1, 3, 5, and 15. Okay, so now that I found my factors, now I need to look at my next word, the common factors, and let's see which of those are the same. Well, in both of these I have a 1. In both of these I have a 3. And that's it. Okay, so I found my common factors. And lastly, I'm looking for my highest common factor. So my highest common factor in this case is 3. So the highest common factor equals 3. Awesome, let's have a look at another question. Let's have a look at 8 and 16. So first of all, let's look for my factors of 8. I have 1 and 8, 2 and 4, 3 and 3, 6, 9, nope, no 3. And if I try and do another 4, I'm just repeating myself, so I don't need to do that either.
So here are my factors of 8. 1, 2, 4, and 8. Awesome. Now let's look at my factors of 16. I have 1 and 16, 2 and 8, 3. Is 16 divisible by 3? 3, 6, 9, 12, 15. No, doesn't look like it. So 4. And then what do we multiply 4 by? Another 4. So therefore, I know that I've come to the end because I've already now used that other 4. So my factors of 16 are 1, 2, 4, 8, and 16. Now let's look for those common factors. I have a 1 in both. I have a 2 in both. I have a 4 in both. I also have an 8 in both. So then now looking for my highest common factor, I can see that 8 is my highest common factor. Awesome. Okay, hopefully you're getting the gist of this. Let's finish off with question 3, which is 5 and 10. So let's start with 5. Factors of 5 would be 1 and 5. And then, do I have any more? 2. 2 times nothing. 2, no, 2 doesn't work. 3, no, 3 doesn't work. 4, no, 4 doesn't work. So we're back to 5. Well, we've already used our 5 and our 1, so we can't do that. So therefore, I only have these 2 factors. That makes 5 a prime number, which we're going to talk about more in our next video. Okay, so we only have these 2. Let's see what we have for 10. I have a 1 and a 10. I have a 2 and a 5. And then I think that might be it. 3, no, 4, no, and then we're back to 5. So my factors of 5 were 1 and 5. My factors of 10 were 1, 2, 5, and 10. Let's look for those common factors, and hopefully we can see we have a 1 that's common, and we also have the 5 that's common. Let's find the highest common factor, which we can now see is the 5. So the highest common factor equals 5. Awesome. Okay, well, hopefully this was useful for you. So what we're looking for, the highest common factor, first look for those factors, then let's find the common factors between the two, and then just look for that highest value, the biggest number. Okay, so here are 3 questions for you. Have a look at trying to find the highest common factor for these. Put your answer in the comment section, and I'm going to try and mark every single one. Okay, you ready for the 2 challenging ones then? The first of which is going to be the commutative property, and what that means in multiplication. Let's see how you get on. Okay, we're going to be looking at what the commutative property is, and we're going to be looking at these 4 example questions here and see how this rule or property applies. So first of all, we can think of the commutative property. Think of the word commutative like commute, which basically means to move. And what it's basically saying is that we can move our numbers in our questions and still get the same answer. And we can do this in both addition questions and the slightly trickier multiplication questions. So let's have a look what I mean exactly, and let's have a look at this addition question, 4 plus 6. When we have the question 4 plus 6, these 2 numbers are actually called addends. So we spell that like this, A-D-D-E-N-D-S. And it doesn't matter which way around we put these addends, we're still going to get the same number. Watch, if I put 4 plus 6, I'm going to get the answer 10. However, if I flick my addends the other way around and I put my 4 on the other side and my 6 at the start, add them still together, 4 plus 6 also equals 10. Let's look at it another way. If I have 4 balls, 1, 2, 3, 4, and I add 6, 1, 2, 3, 4, 5, 6, it gives me a total of 10. And it's exactly the same as if I have 1, 2, 3, 4, 5, 6 at the start, and 1, 2, 3, 4. I still get a total of 10. So addition questions are commutative. It doesn't matter which way around we put our question, we're still going to get the same answer. Let's have a look at it with this second example. 19 plus 100, 19 plus 100 equals 119. But if I flick my addends the other way and I have 100 at the start and I plus it to 19, I still get 119. And if I was a patient person and could draw out all those circles and balls, I could prove it with that model as well. Let's have a look at multiplication then and see if it works here as well.
So 5 times 4. 5 times 4 is 20. But now my 5 and my 4 we don't call addends because we're not adding them. We call them factors because they are the factors of 20. And now let's see if I put these the other way around and put my 5 at the end and my 4 at the start. 4 times 5 also equals 20. Let's have a look at that with our footballs. And 5 times 4 can be shown like this. This array, as we call it in multiplication, represents 4 times 5. And 4 times 5 gives me a total of 20. But now if I flip this array around and put it the other way, this array now says 5 times 4. But we also now know that 5 times 4 still equals 20. So multiplication is the same. It doesn't matter which way round we put our question, we're still going to get the same answer. And let's demonstrate it with 8 times 11. 8 times 11 is 88. But also move mine the other way around, start with 11 times 8, and 11 times 8 is also 88. So multiplication and addition are both commutative. It doesn't matter which way around we put the numbers in our question. Let's have a little think about subtraction and division quickly. Let's have a question, 5 subtract 3. 5 subtract 3 equals 2. Let's see if we get the same answer moving the digits around. And let's have 3 subtract 5. Well, 3 subtract 5, if I have 3 and take away 5, I'm going to end up in negative numbers, and I'm going to end up with negative 2. So I do not get the same answer if I flip these digits around in my question. So therefore, subtraction is not commutative. Let's have a look at division quickly. If I have 15 and I divide that by 5, I get 3. Let's move our digits around, and now I have 5, and I'm sharing it with 15. Well, this is actually quite a hard question to answer, but I know that my answer is 0.33 recurring, and again, definitely not the same answer. So again, division is not commutative. So addition and multiplication are commutative, doesn't matter which way around we put our numbers in the question, but subtraction and division are not. Very important to remember. Whoa, okay, we're nearly there. Let's have one last lesson then. Let's have a little look at the hardest thing we're going to look at today, which is the distributive law. This can be a little bit hard to get our head around, but hopefully I've put this at a level where we can understand it here today. Good luck, and I'll see you in a minute. So first of all, let's just think about the word distributive, because it's a bit of a horrible word really. We can think of distributive like distribute, or to share out. So what is the distributive property then? So we can look at a question like this first example, 14 times 6. And if we couldn't work out 14 times 6, or we didn't have time to do the written method, what we could do is we could distribute the numbers differently. And we could say that 14 is made up of a 10 and made up of a 4. And if I then multiply those individual numbers still by my 6, I can see I get 10 times 6 is 60. And 4 times 6 is 24. And then with my answer, if I simply add this up, 0 and 4 is 4, and 6 and 2 is 8. And therefore, I can get the answer 84. So this can become a very easy method of working out questions mentally. For example, if we have the question 432 times 5, this second example, 432 times 5 is obviously a difficult question to answer, but if I work out quickly what 400 times 5 is, then look at my 30 times 5, and then my 2 times 5, I can do those numbers quite easily in my head. 400 times 5 is 2000, 30 times 5 is 150, and 2 times 5 is 10. And now these numbers are quite easy to add up in my head. I can just add the 2000, the 150 and the 10 to get an answer of 2160. But that's not all that the distributive property is good for. It's also very good for these second two questions, of which this is meant to say 4, of course. So if we look at this first one first of all, 4 times 7 plus 5. I could work this out in the traditional way, using the order of operations and understanding that I need to solve the question inside the bracket first. So 7 plus 5 is 12, and then 4 times 12. And 4 times 12 is 48. Or I can use my new distributive property, And I can understand that in order to do this, I can distribute the 4 and multiply it by the 7. So 4 times 7 is 28. And 4 times 5 is 20. Add these two together, gives me a total of 48. And what you'll notice is it's the same answer in both of those. So the distributive property can be very useful for helping you understand and solve these expressions. Let's have a look at our last one. And again, we can use the order of operations and understand we have to solve the bracket first. 5 multiplied by 9. 5 9s are 45. Or I can use my distributive property and realize that I must first multiply my 5 times 3, which is 15. And then I can multiply 5 times 6 equals 30. Plus the two together equals 45. And again, same answer. So you can see how the distributive property can be very useful for helping to see the answer to expressions, especially when those expressions can get quite difficult. So there we have it. That is the distributive property within multiplication. Very useful for helping us with mental maths, but also to work out expressions. So what should we remember? Distributive is just a nice way of saying to distribute, or to share out, or move things around differently. Distributive property means to distribute or move the numbers around differently. And we can use this to help with mental maths and solve expressions easily.
And there you have it, guys. Hopefully this lesson has been super helpful for you and made you understand everything you're going to need to know in year 4 about multiplication and division. Hopefully you've learned something today, guys. If you have, give me a thumbs up, subscribe to the channel, and I'm going to see you in another video. For now, peace out.